Hi, I'm Julie. Let's learn about ferns in France.
So I'm here in the Dordogne region of France this morning on a little hike, checking out some very cool prehistoric stone carvings, and just wanted to make a quick video about some of the plant life here. So in the spring right now, it's still warming up, so things are still pretty dead, but it's going to be nice and warm for the next few days, so a lot of this will start coming back to life. But what I found really interesting are these ferns. So these ferns are very, very common in this area. Over the next few months, and especially into the fall, they'll get very lush and grow very large. And then they'll actually go to spore in the fall and then die back in the winter. And then right now in the spring is when they're starting to come back up. So you can see some of these starting to kind of unfurl. So ferns are an extremely old group. They predate both gymnosperms, so seed plants like conifers and evergreen trees, and they also predate angiosperms, so the flowering plants. Flowering plants are very pretty recent evolutionary addition to plant life. They evolved, flowering plants evolved probably, we have fossil evidence that dates back to as late as the Cretaceous period. We have found some fossil evidence to suggest that they might have evolved a little bit earlier than that, so as early as the Triassic period. But these ferns are very, very old. So ferns, the earliest fern fossil evidence we have is from the late Devonian, so almost 400 million years ago, which is really, really old. So this is most likely what a lot of the dinosaurs we think of, especially early dinosaur species, were munching on back in the day. And the cool thing about ferns is they are vascular plants. So they have bundles of tissue called xylem that help transport water. And they also have bundles called phloem, which help transport food and nutrients from the soil into the plant. However, they are not seed plants. They don't have seeds. They don't reproduce with seeds, but they do still reproduce sexually. And they have this thing called alternation of generations. So when we think about a lot of plant species, they actually do reproduce sexually. So there's male and female gametes, so sex cells. But in ferns, they have this alternation of generations where they have one part of their life cycle, they're found in what's called a gametophyte form. So what happens after a fern spores, so typically on the underside of a leaf, you'd see lots of these little spores. Because it's spring and these are new, they don't have those spores on the underside yet. But what happens is the spores get released into the air when the plant is mature and ready to reproduce. And then it will actually go and form an independent plant called a gametophyte. That gametophyte contains both male and female sex cells, which is advantageous because it really is good to help ensure reproduction takes place. When you put the male and female sex cells together in the same plant, it just increases the likelihood of that sexual reproduction being able to take place efficiently. So after that gametophyte matures a little bit, it releases those sperm and egg cells, and the plant is able to reproduce. And then once those cells are fertilized, they're able to form what we call a sporophyte. And that's a mature fern plant that we think of that can then live its life cycle and then start all over again. So this is a really cool, just kind of like showing you how lush this could be. These are all dead ferns, all of this brittle material, all dead fern. But you can see some of them starting to come up as it's getting warmer. So typically we call this a fiddlehead. A lot of species are actually edible. People say they taste like asparagus. But you can see a lot of those fiddleheads starting to come up there and form the next generation of ferns.
Okay, so just to show you a little bit of a difference between ferns and different types of plants like I was talking about earlier. So this is a pine cone, which comes from gymnosperms. So pine cones come from things like evergreen trees, conifers, things like that. And gymnosperms are older than flowering plants, but younger than things like ferns. So ferns evolved about 400 million years ago, a little bit less than that, perhaps. But gymnosperms are a little bit older. I don't remember the exact age off the top of my head, but so these are actually seeds. So every single one of these little scales is what we call them. So the scales on the pine cone, if you were to pull one off, like this could maybe. Not plugging myself.
Is it easier to do it at the top ones?
Maybe. Oh yeah, there we go.
Break that.
There we go. So every single one of these could potentially become one single pine tree. So as these pine cones drop on the ground, and different animals can actually eat these different scales, they get destroyed, they decompose a little bit. This whole pine cone can become multiple different pine trees. And the advantage of that is that for every single pine cone, the likelihood of dropping a seed and the seed becoming successful is a lot higher if you have many scales that could all become trees. Similarly, but very differently at the same time. So ferns typically on the underside have spores, all on which these don't because they're not quite to that life stage yet. But typically on the underside, this would be covered in little brown dots that can become millions and millions of spores that then can become that gametophyte life stage where they can grow into early ferns that can then reproduce and make full grown ferns. So they don't have these seeds. And so the spores are a lot easier to be dispersed by things like wind. They can get caught as different animals brush past. They can pick up the spores and transport them. So there's a lot of advantages to having seeds. Seeds are a lot more protected. They're a lot more enticing for animals to eat and then eat, digest, drop them elsewhere. But spores can also go a lot further on the wind. So different strategies that both have advantages and disadvantages.
Do you know? So obviously, like in the fall, it gets the spores, and then
Mm-hmm.
the spores disperse. Do the spores just like lay on top of the ground and then become a fern? Like what?
Yeah, pretty much. So, I mean, the spores themselves basically carry all of the genetic information from the plant. And so as they are dispersed, those spores contain both the male and the female gametes inside of them, and then they can kind of just find a patch that is suitable to them. Not too close to other plants, but close enough. There is advantages to being too close, but not too far away. Sharing nutrients, but not overdrawing nutrients from the area. Um, and that does just help increase their likelihood. That's why you see places like this where in the fall when this is all lush, like this is covered in ferns because anywhere that there's a free spot open, that spore can kind of just drop and propagate. So um, very easy life stage to be able to kind of overgrow a region like this. Whereas if you look around at how many trees there are, which trees are a lot bigger also, so that plays a role as well. But they need a lot more space, and it's a lot more difficult for a seed to drop and become a full tree than it is for a few spores to drop and become a fern plant.
So this is really cool. This is a great example of 3 different phases as these ferns are coming up and starting their bloom for the year. So right here on the trail, we have a fern that is just starting to emerge. So this one's kind of stuck on. Here's another one. And it's just starting to emerge from the ground. So they start curled up like that. And then as they grow, that stem elongates. And then that top is still kind of bent over. And then as they grow more and more, they start uncurling. Then they have these beautiful little curled up leaves, and then they eventually totally unfurl.
Okay, here's another great example of a fern. This is a more mature sporophyte version of ferns. So this means it is reached more sexual maturity. You can see these are the spores on the outside or on the underside of the leaves. So these brown dots are literally millions of spores that they will release. You can kind of brush them off with your finger and release those spores, and those spores will go. They're often wind distributed or just things brushing by. You can pick up those spores.
And then those spores will eventually form into a gametophyte and allow for propagation of the plant. We had a great spring morning here in the Dordogne region of France, walking around the trails, looking at old Paleolithic and Neolithic rock formations. And thanks for exploring all of the cool plant life that is slowly emerging and talking a little bit about ferns with me. See you next time.